Hey there, how are you? I am Pavani. In this video, I'm gonna tell you how to become a data engineer and what are the skills that you need to know in order to become a DE. But I'm not directly giving you the list of skills or technologies that you need to know. Instead, I'm gonna tell you what a typical data engineer does in his role, the kind of products they build, the day-to-day activities or tasks, and then we're gonna decode those tasks, why we do them, the purpose or use case, how we do them, and what are the skills or technologies you need to know in order to do that particular task. So we're gonna do this what, why, and how for each and everything a DE would do in his job. And at the end, I'm gonna aggregate all those skills and give it to you so that you not only know what skills to learn in order to become a DE, but you will also understand why you are learning them and how you are gonna use them once you get into your job. So before we start, if you are new to the channel, please do subscribe and hit the bell icon so that you don't miss any updates. With that being said, let's get into the video. I'm going to see you on the other side of the intro. So, what is this data engineering? What does a typical data engineer do in his role? Well, I can narrow it down into two products. One, data storage systems. Two, data pipelines. So they design, build, and maintain data storage systems and data pipelines. Before we delve into these two, here I will give you two primary skills that you need to become a DE. Be fluent in at least one programming language. It could be either Python or Scala or Java, and be fluent in data language, which is of course SQL. So select one of these languages and SQL, and you need to master them. That is like the basic L1 requirement for any data engineer position. Now let's get back to our two products and let's see the first thing, which is data storage systems. So this data storage system could be a database or a data warehouse or a data lake. Let's see them one by one. So a database is obviously collection of data stored in some organized way. We store them for OLTP purposes. What is OLTP? What is OLAP? I will explain very clearly in a minute. So the task here for DE would be designing or building or maintaining a DB, and that could be either a SQL DB or NoSQL DB. Use case, I will give use case of database and data warehouse together since it will best serve to understand the difference between these two. And the skills you should have for this are obviously you should know SQL. We talked about this. You need to understand the concepts of DBMS, and coming to technologies in SQL DBs, you need to learn any one of these database tool, MySQL or Oracle or DB2 or Postgres, any one would be fine. And also any one in NoSQL DB, MongoDB or Cassandra or DynamoDB or Redis, any one of your choice. Let's move to data warehouse now. So a data warehouse is also same as database, which stores data in some organized way, but it's for OLAP purposes. Your task is to either design or build or maintain a data warehouse for your organization, and the skills you should know for it are obviously you should know the concepts of data warehousing and any one of the DWH tools. It could be either Snowflake or if in cloud. For AWS we have Redshift, for GCP we have BigQuery, and for Azure we have Synapse. So for coming tools also, I will provide services offered by each of these clouds. Maybe just choose one cloud here. Suppose if you choose AWS, you can stick to AWS service in data lakes and pipelines as well, so that you will gain that expertise in at least one cloud services. So that's about it. Now let's see the use case for both database and data warehouse now. Let's say we have a e-commerce website like Amazon. There are a lot of transactions being processed here by each customer every second. We need to store all the data like customer ID, items in cart, product ID, price, quantity, etc. And these should be stored in the fastest way possible, almost with no latency, because we need best possible user experience. So we want a right optimized backend database, which is OLTP, stands for online transactional processing. So we use OLTP-DB when there are a lot of writes and less or no reads required. So as a data engineer, you might be expected to build this. And let's say you completed your task as a DE and built one DB. But why are we even storing this data? We not only need this data to track the transactions, but also for our data analysis purpose. So can we do this data analysis by directly reading from this backend DB? No, because remember, it's only write optimized and it's not at all feasible to frequently read from this system. So we need to transfer this data to some read optimized DB, which is OLAP, online analytical processing, and which is our data warehouse. When we store the data in data warehouse, it is very efficient for data scientists or analysts to read the data from here and perform their analysis or build ML models or dashboards. So to perform any data analysis in the organization, data has to present in the data warehouse, and a data engineer job here is to design a data warehouse based on the business use case, like what are all the fields that we need to store, the present and future size of the data, and how frequently the data has to be updated, which we call as velocity. So by keeping all things in mind, a data engineer has to design a data warehouse which is very efficient for the given business scenario. Once the design completes, we have to build this into a real system, and once we build it, people will start using it, so we have to maintain the DWH and continuously optimize it according to the changed requirements. Now we know what database and data warehouse are, why we need them, and what to learn in order to build them. Let's move to data lake. So a data lake is another kind of storage system. While DWH is the traditional system which is being practiced for some decades now, lately with the exponential growth in the generation of data, we could see organizations employing the data lake practices. So a data lake is basically vast pool of organizations' raw data. Not well organized like DB or DWH, mostly we see unstructured data here, and the kind of data for which purpose or application hasn't been specified yet, but it's possible to use that data in the future. So you design or build or maintain a data lake. Use case, basically you need to build a storage infrastructure that avails to store any kind of data with vast amount of storage capacity. And that data could be clickstream data from websites, multimedia data from social media, census data from IoT devices, log files from any of your company's application. And you could build this on any cloud storage. Skills you need are you need to know storage concepts and data lake concepts and storage services in any one of these clouds, AWS S3 or GCP storage, or you can even do it with the help of Azure Data Lake services. So if you chose AWS Redshift in warehouse section, maybe you wanna stick to AWS here also and choose S3. Likewise, stick to the same cloud for other services as well. So as a data engineer, you might be expected to build data lakes and maintain them. Now we know about data storage systems. Let's move to second one, data pipelines. A data pipeline is to transfer the data from one data system to another data system. As a DE, you have to design or build or maintain a data pipeline. We had talked about OLTP and OLAP and why we need the data to be present in OLAP, which is our data warehouse or data lake, in order for data scientists or analysts to use this data. Well, we are going to need data pipelines to move this data. So a data pipeline fetches the data from source, applies any transformations we need on the data fields, like I need date in specific format, so I need to transform this particular field, or maybe round the percentage field to only 2 decimals. Based on business requirement, we apply transformations and loads the data to the destination. These we also call ETLs, extract, transform, and load. Nowadays, organizations are also following a new practice called ELT, extract, load, and transform, where we are simply extracting the data and loading it to the destination without any transformations performed. The transformations will be applied on the destination side by data analysts based on their use case. So as a DE, you need to build these pipelines. Now, what skills you need for this? We have already established that you need to know any one of these programming languages. So can we build a pipeline by just using this programming language? Let's see by taking Python. Maybe we will just read the data and source using some Python database connector inside the program, apply the transformations using a data frame or any other similar construct, and finally write the data to DWH using some connector API. We can do this, but it's not feasible at all, because the challenge here is not just moving the data from here to here, but the size of the data and the time we have to move that. Let's say you are processing it in one computer, and to apply all the changes you need, the program takes 1 hour for 1 GB of data. Your business might be generating 10 GB data daily, which should be available for analysis by next day. So it's gonna take 10 hours for you to process it and load it into data warehouse. So what if you have 50 GB of data? If you process it in one computer at this rate, it takes 50 hours and you can't load all the data in DWH by next day. Also, pipeline can break anytime. This is where we use distributed computing. So instead of processing all our data in one computer, we split the 50 GB into 50 partitions and process it in a cluster of 50 computers parallelly. So by distributing the work between 50 computers, you can complete 50 hours of processing in 1 hour. This is an example. In real world, we can see much larger data in terabytes or in petabytes sometimes, and clusters have thousands of nodes. So to achieve this, you need to know the concepts of distributed computing. And coming to tools, for this we have Hadoop MapReduce and Apache Spark. Both of these are distributed computing engines. MapReduce is a traditional tool, and Spark is latest, which processes the data 100 times faster than MapReduce. So you might want to prioritize learning Spark than learning MapReduce. And you can program your Spark applications in any one of these languages. And we almost have all cloud services providing Spark service in the cloud. So for AWS we have EMR, for GCP we have Dataproc, and for Azure we have HD Insight. We even have Databricks. So these services offer Spark readily available clusters on cloud. It's not like you have to learn an entire different tool here. Since you are already learning Spark, you just have to familiarize yourself with any one of these platforms. To be able to run your Spark application here shouldn't take much time. And if you need real-time streaming of data, in Spark itself we have Spark Streaming, or we have Kafka. I'm afraid you're gonna feel overwhelmed here, so to ease it off, let me speak a little bit about my skill set here. I'm a data engineer with 3+ years experience, and I never worked with Spark Streaming or Kafka yet. All the pipelines I have built up to now in my past and current companies are batch processing, for which I only used Spark with Python API. Although my current project doesn't gonna need Kafka, I'm planning to learn it in near future. My point is, it's okay even if I don't know Kafka now. I'm only learning it to improve my skill set. It's important for you to understand that you don't need to know all of these technologies on day one. As a DE, you will always have opportunities to expand your knowledge gradually. These are all the technologies that are mostly used in data engineering domain, but not necessarily used in one project. And you don't need the expertise in all of this. Maybe just start with programming language and Spark. Eventually you can learn remaining based on the demand in your project. That being said, let's get back. Along with this tech, we also have managed ETL services by cloud platforms like AWS Glue, GCP Dataflow, or Azure Data Factory. And coming to orchestration, we have Airflow and OG, and Airflow is the mostly used right now. Why we need orchestration is when you build the pipeline, you are just writing the program. For that program to execute and process the data daily, you are not going to go and trigger that manually every day. You want it to be automated to run every day at some particular time. And in real world, the pipelines could be very complicated. You might want to maintain dependencies between them, like I only want to load this particular data after that particular data is processed. Like that, you might be having 100 dependencies. And also you might need to maintain alerts of sending mails on completion of pipeline or failure of pipeline. So to do all this orchestration, you can simply use Airflow, and it is very simple tool that you can learn it in like 2 or 3 days. So this is all about what's, whys, and hows of a data engineering role. Congratulations, you made it to the end of the video. Feel free to comment any questions or suggestions. Thanks for watching.